there, seventh graders. Happy Friday. So today we are going to continue what we've been doing for the past couple days, figuring out if we have a proportional relationship or a non-proportional relationship. All right, so remember to do that, we are looking at unit rates and comparing them from the tables. That is because next week we'll start looking at equations and matching equations with tables and graphs and seeing if they are proportional or not. Okay, so let's look at these two for a quick review. If I have this table of how many weeks and how much money Matt is saving each week, and then I have Jane saving money too, the same amount of weeks, will I see which one of these actually is proportional? Okay, so with Matt's, you're going to compare your dollars and your weeks. The first one, obviously, you want to take 15 divided by 1, which is 15. Okay, then take 28 and divide that by 2 to get your 14. And then take 39 and divide it by 3 to get 13. Okay, so that's the unit rate for each of those ratios for that one. Then, if we look at James, she put $11 in on week 1. At week 2, she added $11 more for 22. So that means we divide 22 by 2. Then take your 33 and divide that by 3, and we get 11. So if you notice, one of these has the same number each time. And when that is a key thing for anything proportional, all of our ratios need to match the same as a key definition to a proportional relationship. So which one would we say is proportional? And explain our reasoning. So we would say that Jane has a proportional relationship because all the ratios are equal. And if we were to be asked what's the constant rate or how much is she making per hour, she is putting in, or actually for this one, it is $11 per week that we are putting in there. Okay, so she is saving $11 per week. Whereas Matt is putting in random dollar amounts throughout each time. Okay, so let's look at our guided review in our textbook. This is page 36 in volume 1. Okay, so the Vista Marina rents boats for $25 per hour. In addition, there's a rental fee of $12 for the charge of fuel. Okay, so we need to put in and find out if this is a proportional relationship or not. Say you go to rent and you don't even make it a full hour. You are still paying that $12 for fuel. Okay, but then for 1 hour, you are also going to be charged $25. So that's where you're going to have to take your 12 plus 25. So that is $37. Then for 2 hours, you're going to be charged another $25. So 37 plus 25, that makes 12 and $62. So then we want to compare our proportions. Okay, so 12 divided by 0, technically that is undefined. Okay, or the 0. Then take 37 and divide that by 1. We get $37. Okay. Then take our 62 and divide that by 2. 2 goes into 6 3 times, and 2 goes into 2 1 time. So when I look at these, I am not seeing the same number. Okay? Yeah, they're both in the 30s, but they are not identical. So we would say that this is a non-proportional non-proportional hours to total cost. And why? Because the ratios are not equal. And that is the easiest way to explain if something is not proportional. They don't equal, not the same. Okay, so let's look at number 2 then. Which situation represents a proportional relationship between hours worked and for Matt and Jane? So we did this one actually in class before, and what you wanted to do was take each one of these, and they're already set up how we would get them. So this one equals 12, this one equals 10, and this one is 10 once. Can't go into 1, 10.3 repeating. Okay, so I can already tell Matt does not have a proportional relationship. So if I take 12 divided by 1, I get 12. 24 divided by 2 is 12. 36 divided by 3 is 12. So James is proportional because she makes $12 an hour. And the reason why we know that is because all of these equal 12. All right. Building on our essential question, explain what makes two quantities proportional. Well, when both ratios reduce to the same value. Okay? Just like when we know a half, that is the same as 4/8 because they both reduce to a half. Okay? That's an example of how two quantities can be equal. Okay? All right, let's actually look at number 1 of your homework. So your homework is page 37, doing 1 through 6. Now, some of these problems do have an A and B section to it, so you need to make sure you do both parts. Okay? So an adult elephant drinks about 225 liters of water each day. Is this number of days and the water supply last proportional? Okay, so what we want to do, the first day, how much water is this elephant drink? 225. After 2 days, how much has the elephant drank? Well, if we add up another 225, we get our 450. Okay, so if you notice, each time we are increasing by 225. And increase again by 225. Okay, so then we get 675. And then we get 900. Right? So if I took each of these and reduced them down, I want to know, is 225 over 1 equal to the same thing as 450 divided by 2? That's what we're kind of looking for here. Do all of these actually equal each other? Because if one does not, then it is not proportional. So that's where we can actually reduce 225, 225, 225, 225. So yes, this is proportional. So you would answer in your question, Okay? You would actually answer that all the ratios equal, well, they kind of flipped it the other way. It would be 25. Because remember, we always take our y over our x when we do these. Okay? And then the elevator descends, or it ascends, so that means we're going up. Okay, so you're going to increase. So make sure you go through each of these, read the question carefully so that you are fully understanding what the question is asking. All right, other than that, have a great weekend. I finally got the gum out of it. See?